So, grade 12, as you know, we have finished from our lesson, which is logarithmic function, and we have started with our worksheet. We've already solved 4 exercises. I'm going to go back and resolve with you exercise 3 and exercise 4, okay? So I'm going to start first with exercise 3. In exercise 3, we have given a function f, which is x plus 2 ln x over x. We need to calculate the limits of f at 0 and plus infinity. If you replace 0, ln 0 is minus infinity over 0 is minus infinity. So the limit when x tends to 0 is minus infinity. That means I have an asymptote, which is x equal to 0 vertical asymptote. Now we have a limit when x tends to plus infinity. Of course, here we will have indeterminate form because ln plus infinity is plus infinity over plus infinity. This is IF. So we are going to do Hopital rule, which is the derivative of the numerator over the derivative of the numerator. We will get 1 over x over 1, which is 1 over x. Now, if you redo again, x tends to plus infinity, this is 0. And here we have plus infinity. So the final answer will be plus infinity. Now we need to prove that the straight line y equals to x is an oblique asymptote. How do we do this? First, we should find f of x minus y. And f of x minus y is 2 ln x over x. Now we need to calculate x when tends to infinity. It should be 0. We've already calculated this using Hopital rule. So 2 over infinity is 0. Uh, so y equals to x is an oblique asymptote. And now we need to study the relative position between the curve and the straight line. So yc minus yd is 2 ln x over x. If you put this equal to 0, you will get 2 ln x equals to 0, which is 1. So at x equals to 1, the line D intersects the curve C at 1, 1. But between 0 and 1, the curve will be negative, according to the, if you do a small table that we used to do, here we have 1, okay, opposite, same. So between 0 and 1, the curve will be below D. Between 1 and 1 to plus infinity, the curve will be above the line D. Now, we finished. Here we have the table below is the table of variation of the function f prime, which means here we have the table of variation of the derivative. And we are asked to show that f is increasing over its domain. How can I tell that f is increasing? F to be increasing, the derivative should be positive. If you look at the table of variation, the minimum of the derivative is positive. It's 1 minus e to the power minus 3, which is a positive. If the minimum of the derivative is positive, then the derivative is always positive, means that f is increasing over its domain. So we say that the derivative is always positive, then f is always increasing. And this is the table of variation of f of x. The derivative is positive and f of x is increasing. Now we need to calculate the equation of the tangent to the curve at point E. The equation of the tangent is y equals f prime of E into x times E plus f of E. So you replace in the derivative E, so we will get E plus 2 over E. And we didn't calculate the derivative. How can I tell that f prime of E is 1? I go back to the table. F prime of E is 1. So you take it from the table. And f of E, you replace it, of course, in the original function. So f of E is E plus 2 over E. And now the equation will be x plus 2 over E. Now the common question is, show that f of x equals to 0 admits a unique root alpha and verify that alpha is between 0.75 and 0.76. In order f of x to have a unique root, it should be either increasing or decreasing from a negative value to a positive value, or from positive value to a negative value if it's decreasing. If you can see, f of x is increasing from minus infinity, which is less than 0, to plus infinity, which is greater than 0. So, of course, it admits a unique root alpha. And how can I tell that alpha is between 0.75 and 0.76? You calculate f of 0.75 and f of 0.76, the product should be negative, and of course it's negative. That was the first exercise where we used a table in order to tell the sign or the variation of the function. Okay, now we are going to start with exercise 4, where we have two parts. Part A, where we are going to set up the table of variation of a certain function. And here we have part B, which is related to part A, because at some point the derivative will be joining those two functions. Let us start. So we have the function g of x, which is minus 2x squared minus 1 plus ln x, and we need to calculate the derivative. The derivative of this function is minus 4x plus 1 over x. So it's minus 4x squared plus 1 over x. And now we need to calculate the limit at 0 and plus infinity. If you replace 0, of course you will get minus infinity because ln 0 minus infinity. And if you replace plus infinity, you will have an indeterminate form. So we take x squared as a common factor. And after calculating the limit, you will get minus infinity. Of course, here you will have IF. So you're going to do L'Hopital rule. So at the end, it's going to be minus infinity. And now we need to table variation of g, so we take the derivative equal to 0. So we will have two roots, plus 1 over 2 and minus 1 over 2. Minus half is rejected because it's outside the domain. So the only accepted solution is 0.5. So opposite, same, plus and minus. So this is the table. Remember very well because you are going to use it later on. Now deduce the sign of g of x. In order to deduce the sign of g of x, I have to look at the maximum of the g of x. What's the maximum of g of x? It's minus 2.19. If it's the maximum is negative, then g of x is always negative. Do we agree with this? So if the maximum of a function is negative, so of course it's negative for every x, okay? Now we will have a new function, which is f of x equal minus 2x plus 1 minus ln x over x. We need to calculate the limits of this function. At 0, you will get plus infinity, and at plus infinity, you will get minus infinity. And now we need to prove that this function or this equation is an oblique asymptote. The same steps, f of x minus y, limit at x tends to plus infinity equals to 0, then this equation is an oblique asymptote. Now to study the relative position, we put it equal to 0. So we have x equals to 1. If x, the same table, we do it again. Have a table. This is the root. Okay, here we have minus or plus minus. So between 0 and 1, the curve is above the line. Between 1 and plus infinity, the curve below the line. Those are very important because when you want to draw the curve, they show you how the curve, if it's below or above the asymptote. Now the most important question is, show that f prime equals g of x over x squared. After calculating the derivative, you will get minus 2x squared minus 1 plus ln x over x squared. If you want to do the study sign for minus 2x squared minus 1 plus ln x, you will not be able to calculate the roots because you have two functions. So you go back for g of x, okay? When does g of x equals to 0? G of x is not equal to 0 because the maximum is negative. So this derivative is negative. It takes the sign of g of x. So the sign of f of prime of x is the same as g of x. So it's negative for every x, plus infinity to minus infinity. Now you are asked to write the equation of the tangent. Again, it's y equal f prime of 1 into x minus 1 plus f of x. But this time we are able to calculate it because we have already the derivative. So, do you still remember the relative position between 0 and 1? We said that the curve is above the line. The curve is above the line. It cuts the line at 1, and then it goes downward, which means below the asymptotes.